The practical guide to MLOps, QR code, scan if you want to join the LinkedIn things I do, because I chat a lot about stuff, I guess. Also, as Kasper said, I'm one of the organizers in the Aarhus community. I actually was part of founding Cloud Native Nordics together with Kasper. I think that's pretty amazing that we can do such a big conference in Denmark. I'm still a CNCF ambassador as far as I know. I haven't been put off the list, but we still don't know if we are accepted. It's confusing these times. So please remember your towels. It's very important when you're a hitchhiker to remember your towels. You don't need when you need them. You'll just need them at some point, right? And in reality, this is the practical guide. So this is what happens in most companies these days. The CXOs want AI. They don't know what they really want, but they want it as of right now. How many of you have talked with leadership, management, and they want AI, but they cannot explain? That's a lot of people. That's interesting. And AI and data is a new workload we have to figure out, right? So we got this mess of abstract art, which we now have to run inside our clusters and data centers. And in reality, it looks sort of like this. Yes, it is AI generated, but this is AI land, and we are apparently here because the CEO said so, right? And there's a lot of stuff going on in AI land, and I will post this on LinkedIn later so you can see it, but there is some AI strategy we need to figure out. We need to figure out artificial intelligence in general, right? We also need to figure out sort of the bottom part here. You can see there's a lot of servers, and some of them, I guess, have graphical cards and network and stuff we still need, right? But as Abdel said, the containers are getting large, and we're speaking insanely large. Most of us focused on doing small containers. Apparently, when you go into generative AI, everything explodes and gets big. So we need to figure this out. And in general, generative AI is what I call, what you call AI most days. Or I call it machine learning, but we will get back to that. But generative AI is these language models, right? Stochastic parrots, as in randomized parrot talk, right? That's what they're good at. The best use cases I've seen out there is taking unstructured things like emails and putting it into a structured format. Brilliant solution. Don't use them for doing your taxes or anything, because they're not very good at that. Then we got, obviously, large language models, which we call LLMs. Abdel talked a lot about this, so I won't cover it, really. But often they are hosted as SaaS solutions, right? You just buy them. You buy API access. You pay per token. What is a token? Well, that's too confusing to explain. You just pay per token. And they are sort of easy to handle because they are another body's problem. How many have OpenAI running at home or in Azure? At least 20 people or so. Apparently Microsoft don't want to give them more graphical cards, GFX, NVIDIA, whatever, compute. So now they are moving into Oracle data centers, which is fairly interesting, because I will say that's new meets old. In some ways. And let's hope Oracle is very good at running workloads, so let's hope it's gonna work, but it's someone else's problem. But if you do sort of smaller language models, or you're crazy and do large language models yourself, you can actually host them within your own environment. That's interesting for a lot of people, I think, in here. And actually, if you want to do this agentic thing, what we are seeing is that small language models that are tuned to a specific purpose are way better than large language general purpose models. So I think a lot of you will actually have development teams or be part of development teams that creates things that run small language models within your infrastructure. And running it in your own infrastructure is interesting because for a long time Kubernetes was about stateless, and now we have a shit ton of state. There's really a lot of state in AI. So we need to handle that. And we also have these gigantic binary files that we move around. And what I'm going to talk to you about today, because it's easier to reason about, I think, is classical machine learning. That's what we have been doing since the 60s. This is a neural network, if you were wondering. This is how they look, apparently. It's just layers and layers of neurons doing transformations and filters on your data. And we do this to do either classifications, are this a cat or a dog, predictions, how should we trade our energy, what stocks should we invest in, how much clothes can we sell, how much coffee do we need to brew for a large conference in Aarhus, stuff like that. Then we can do associations or clustering where we say, is this similar or different from what we have seen previously? And then we can do decision making in general, so help people make informed decisions based on data. That's sort of the whole idea about AI. Building and operating AI is different from especially state-less workloads because it's very stateful, and we need some data to go in, and we need it sort of twice. So first step is we need to train something, or you buy a model and put your data on top and then retrain it. But the classical way is take an algorithm of some sort that can learn. You can find 1 million of those on the internet. Most of them are open source. Thank you, all the universities in the world. And then you have your data, then you train, figure out how it works. It looks something like this, because it's basically Frankenstein's laboratory. We don't know what actually works, so we just try things. The solution space is so enormous that we cannot calculate what is the right solution. So if you have met a data scientist that is just throwing signs at the wall and seeing what sticks, this is actually how you do it. It's pretty random. And at some point, you will end up having a model. This is your binary file that contains all the weights and everything that the model knows about the world. So the patterns you have decided that it should learn is embedded within this model. This is what OpenAI does. If OpenAI wanted to train a new ChatGPT thingy-madingy, that would take approximately 6 months of just training until you have a model. That's fairly long. For smaller classical machine learning workloads, you can do it in minutes. But we need to run these ML models in our platform, right? But what if we could use the platform for both the training part and the production part, which we tend to call inference? Inference? Yes, machine learning was invented at universities, and you don't get PhDs or doctorates on words that is already known, so inference. There you go, and that looks something like this. Anybody can remember the phone number you need to call if you have a fire? Oh, okay. So MLOps. In general, that's about tech and people, because we need the AI to produce some result that we give to some people to do something. Or you're just insane and trade a lot automatically, which some of you do in here. But there is actually a pretty nice white paper. I put the link in here, but you can also just search for Cloud Native Artificial Intelligence white paper. And they actually try to explain it to Kubernetes people. How should we do this? And as you can actually see, a lot of the things that we are good at and have been good at for 10, 15 years is still worth being good at in the AI world. So we still need CI/CD. We still need to figure out the platform underneath. There will be infrastructure, and there definitely will be hardware. That's not going away, right? So the only thing that actually changes is up here. Now we have these data ML AI engineers doing a lot of things. That looks something like this. An ML engineer gets a task to solve something in the business. They prep the data. They do some feature engineering. Maybe they have a feature store to save the features in. What is a feature? Well, if you just think of Excel and look at a column, that's a feature. If you combine 2 columns, that's a new feature. Why features? Well, back to the PhD part, I think. And then you train the model, you store it somewhere, and then we can have pods spin up and serve requests, right? And then rinse, repeat. That's sort of it. And I have done something pretty crazy and created a live demo of that. So let's see if we can run that through. We also have this thing you need to be aware about. Very, very, very aware about. The EU wants responsible AI. So they created an act, the AI Act. And in general, the idea is that you cannot do anything that will risk the health, safety, fundamental rights of a EU citizen, which is fairly nice. And then it states, except if you're the police or intelligence or military, then you can do whatever you want. But the idea is for all of you, at least I don't see anybody from the military, but maybe you're here, then you can do whatever you want. For the rest of you, you will have to do responsible AI. And actually, there are parts to this. So if you end up in the high-risk system, as an example, you trade a lot of power, or you move power around, or heating, or something like that. Money is also fairly important to have figured out. Then you need to figure out all of these requirements, because these are the requirements to high-risk AI. I will show you, if the demo works, we hope so, that we can actually do these 4 parts as an automated process, as part of the MLOps flow. I hope it really works, because here we go. So the idea about the demo is that we have a factory somewhere. Maybe they produce windows or bricks or something, and they want to know when do machines break, because then we can maintain them before they break down, right? And that's important if you produce Lego bricks, because apparently everybody wants Legos these days. The architecture is like this. I'm using RabbitMQ, not Kafka, because Kafka is way too complicated. RabbitMQ, good old nice technology for queuing. I like it a lot. There are 2 queues, one with sensor data and one with the machine state. So is it healthy or unhealthy? And then we pull it in the lower part and do the training, transformation of data and training. And then we deploy the model also inside Dexter. Thank you to Andrea for telling everybody in here about Dexter, so I don't have to. And then we can predict breakdowns. This is sort of the demo. And I'm using RabbitMQ, Dexter, something called Polars, which is better than Pandas. Do you know why Polars is better than Pandas? Ice bears. They are more cool than pandas. No, you haven't heard that joke? Okay. And then a very old library, actually, that is sponsored by the French government. Yes, the French people are insanely good at open source. We should do more things together. sklearn. And you can sort of watch all the code in there if you want. Let's see if it's working. Oh, all my windows moved around. That's nice. So here's a RabbitMQ thing doing its thing. This is Dexter running in developer mode. As you can see, it keeps telling us something about a queue not having data. So I just created some nice things where I can create some readings. So now I will just publish a couple of readings. And we will also do some machine state. As you can see in Dexter, it has now sensed that there's data going in and is doing stuff. We can actually see that as a website as well. Let's see if I can find it here. So it has the 2 queues here, which uses Polars to do some things with and then save them as a file. And you can see that there are, one of them is materialized. That's because we have assets that is declaratively defined. And then we materialize data on that asset. It's a different way of thinking about data pipelines in general, because we tend to do them imperatively, but doing it declaratively is definitely the way to go. It's way easier to reason about and debug, because it will go wrong. And as you can see now, it has done all the things, which is the ingestion part. So data exists, we took it in, created files, yada, 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 or saved them in a blob storage or database, whatever you want. And then we have the model training part, which is basically doing some Polar stuff, where we split the data and then train a model. Let's see if it works. This is interesting. And everything in here, every job is spun up inside a job container, and when it finishes, it's just killed. So the only thing in Dexter that is running continuously is basically the control plane, and then the data plane is ephemeral. So it just exists and then dies. Fingers crossed. Please don't break. You can do it. This is taking a long time. Oh, we did it. That's great. So now we actually have a machine learning model over here. I have chosen to make this demo continuous delivery and not continuous deployment. So I actually want to be in control over the model that is in production right now. So we can do a materialization here. And if we are lucky, I should get some different models I can choose from. And then I can actually deploy that model. But it's up to me as a human to decide what I want into production. Yes. See. Can you see that? Should I zoom a little bit? There's a list here of models. You can see that I did a demo way back, and then I sort of trained it yesterday, and now we're taking the model from today. Let's see if that's a good model. Because in machine learning, sometimes you don't get good models. Then it's more like cows than pets, right? Then you just kill them and create a new one. I guess that's what you do. I'm not a cow farmer. So basically this step takes some configuration. Yes, that's YAML. And you can actually get Dexter to scaffold it for you. So I only have to put in the optional value here and then press materialize. And then hopefully we will get a model into production now. So now that's actually running. And now we have sort of done the part where we trained things, got data in, trained things, put it into production. So now we go into what we call inference, where we want to use the model for something. And the training just gives a binary file. Just think of it as a binary file. It's basically all the model parameters embedded inside a file with some metadata. We moved that into production, and now it's running. And now we can publish some more data, new data that the model has never seen, and use it in production to tell us which machines are working and which are not. I'm insanely happy about this bash script right now. As you can see, Dexter is currently looking and seeing that there's data, so now it's just starting jobs to import the data again. And that was the wrong way, here. Now you can actually see it turned blue because work is happening. And you can also see that there is a little dot up here where it states that it's unsynchronized for now. So new data happened, I'm not synchronized the whole way down. And you can use that to do clever materialization policies. For now, it doesn't really create a new model, but if you got some new data, you could set it up so you just create a new model, A/B split test it as an example and put it into production, right? Let's see if we can get some machines at risk. I guess machines could also be servers, so it could also be which servers are breaking down. Up to you. Yes, and let's have a look-see. And here's a list. That's a lot of machines. The funny thing about this demo is that either there is a million machines breaking down or two. So if we try and train a new model, then sometimes it turns into that there are only two that will actually, oh, I need to click here. Turn into that there's only two machines breaking down. And you need to sort of catch this before you put it into production, because this is where it gets stochastic, right? It's random sometimes. And we put in a lot of random parameters, so you cannot be certain that a newer version of a model is better. And that's very different from running software, right? Because we want to, at least for the patch or the minor version, we want to sort of update. But it's not the same in machine learning. You will burn your beautiful fingers on this one. Now it's training a new model. Should we have a look? This overview gets crazy complex when you have very large pipelines. That's why I break them up in smaller parts, so you can actually see it. Oh, there we go. And you actually, I haven't shown you this, but look, I have logs. So I can actually see what goes wrong if something goes wrong. But right now, this demo is going fantastic. Let's materialize this and get some new candidates, because we have a new model and I just need the list, so I don't have to go into my file system, because apparently I do websites now. Let's deploy a model, materialize, scaffold the missing config, put in a name, deploy. Awesome. Version 2 going into production. Let's see what happens if that is set to predicts. As you can see, it has that little yellow icon, which means that it's unsynced now, because new model still needs to see the new data to make it work. And oh, still a long list. Okay, so it didn't do what I hoped for you to see, but it will change, I promise you. And that's sort of one way you can do this. I just chose some tools, right, and bundled it together, but I think the concept is what is important. Then I told you about model cards, right? You have to do those on high-risk AI systems. So what if, as part of the model training, we have a markdown template, and then we took all of the training data we produce, either how, sort of accuracies, CO2 emissions of training, whatever you want, and then shove them into a model card. And model cards, if you want to, you should just Google model cards, right? Use favorite search machine, Google model cards. They produced a standard for telling you how to sort of present model cards. I think it's fairly good, so please use that. This is the model card for predictive maintenance on component 7, apparently. The development team was Renee, which is one of our engineers, and me. I also fixed things. As you know, the answer is always 42, because that's the sort of how it is. Here's the architecture, here's all the model details we have trained today, here's how much CO2 I just used. Estimated, of course. Not all the input data it have seen, all the examples, yada, 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 yada. Right, validation scores. How did it do training-wise? That's I would tend to say overfitted ML model. Do you know how an overfitted AI model looks? It's the guys that go too much in fitness, so they have to take their phone like this, because their arms are too big to do this. That's an overfitted model. You shouldn't do that to your body, and models shouldn't as well. That's just too much. So that's the demo. And in reality, what you just saw is the ingestion of data, model training, deployment, and inference. And it could have been totally automatic, so I shouldn't do anything more than just publish the data. And as you know, the answer is always 42. The only thing you need to figure out is what is the question. And this is where it gets a little bit abstract, but if you change 42 with AI, it's sort of the same thing that's going on right now. AI is the answer to everything. But what is the question? And I really do hope that you as engineers, leaders, tech people want to understand what is the actual need, because else we're going to end up with a lot of crappy AI in production that doesn't really bring value. So please seek out the business value. Thank you so much for your time.